we're going to be practicing some of the skills that we talked about in terms of feedback with children that both fosters learning and helps their resiliency and helps them develop the social and emotional learning skills that we know are crucial to mathematics. We're going to do it in the context of two highly engaging math tasks that I would be using in our study of ratios and proportional reasoning. In your groups, and you know I tend to organize group work this way, you have a folder. It has a task card in it and individual worksheets. You're going to look at the task card, work through the tasks. You won't have time to finish them. What I want to use these tasks for is first, what is it? Part of how we work with children's attitudes towards math is we offer engaging, rich, challenging, fun tasks where they can use mathematics to explore relationships, to model with mathematics, and use mathematical tools to understand things that are interesting. Because then we're going to take student work samples from these tasks and the follow-up activities and talk about, okay, what's the formative feedback you would use for this work sample? That's where we're going. Okay? Go ahead and begin.
Our task is to explore the relationship between the circumference and diameter of circles. We will measure the circle imprint left by the bubbles and record our measurements on a table to compare the circumference to the diameter using ratios. So what we want to do is, everybody needs a straw, and then you go ahead and open up the bubbles. It's not submerged. Okay, blow. Keep going until it pops. Woo! Okay, so now that you have this outline, measure the diameter, the string for the circumference. Okay. 8.
Let's see, 2 and a quarter.
2 and a quarter?
Let's do diameter. String it twice. 23? Is that centimeters? Yeah. Like right here? Mm-hmm. Oh my gosh. Here, you want to lay it down? Yes. And then you pinch it off. So there's 12. Mm-hmm.
Well, he started to slow down near the end of the second year, it looked like. Because remember, he was like right here, he started to go sluggish.
Well, okay, here's the thing. So we know...
That's why it took a little longer than...
Yeah, it took a little longer to go twice the distance, but just a little bit, so...
That, because it was hard to call it right at 2 seconds, well, and clearly from our first set of numbers to our second set of numbers, it was... Our toy is dying. What happened to our toy? Oh, here he is. He's not doing very well. He's sickly. He's sickly.
Whoa, what do you do in terms of this? And how do you want to try and capture that mathematically or model it? Or do you want to try and control the situation? Lots of times kids just put it right next to the meter stick and they use the meter stick to keep it straight. But those are the things I want kids to talk about. But I'm hearing some really rich discussion around what do you do with real data? And how are we using mathematics to try and represent that data? And I see many graphs even to model mathematics with what does it look like on a graph? How does the graph tell the story of what's happening with what you're doing in your group? What are the relationships between the numbers? We're going to talk about this, and we're also going to look at some student work samples that came from this activity. And then you will recall in my class, I'm always saying, yes, sometimes I do stuff like this and it's deep and it's rich, but they also need to practice the skills of calculating a unit rate. You need to do it frequently so that you remember how to do it. And I'm going to give each group a different student product. And I want you to take some time and talk about that product and think about what would be the learning feedback. What would be the feedback that you might do in terms of forming the respectful community you want? Or is there an opportunity to talk about growth mindset and how effort and diligence and putting forth and embracing challenge actually leads us to get smarter?
So it looks like she's just having trouble remembering that extra step because the relationship between a radius and a diameter, she's forgetting that a diameter is half the radius. So we can always approach the formative assessment by going, oh, you know, it looks like you really got it about the, you know, when you have a diameter, you can multiply and figure out the circumference, but do you remember the relationship between a diameter and a radius? And then we'll kind of go through the problems and then maybe even show them the difference of the, you know, C equals 2 pi r and C equals pi d and and why is that, and kind of just go through with them. That's how I would approach it.
Because that's all. I mean, she's doing the same thing when she has diameter as she is with radius. Those are not the same thing.
So a simple clarification, you could say, you know, your calculations, my gosh, you're showing your work, you're using pi, you're doing it all right, you're simply substituting radius and diameter as if they're the same thing. And here's another thing you want to teach them to do. Go back and look at your book. Oh, you don't have the books. You do have the books.
Yeah, we have the books.
Take a look and look at the difference between radius and diameter. And then when you think of the bubble activity, which were you multiplying by pi? The diameter or the radius? And now I refer it to this highly engaging, I call them referent activities. The bubble measuring is a referent activity for me. So think back on the bubbles. Were you measuring diameter or were you measuring radius?
She has the formulas in her book. She has this visual. Yep. She has this visual. So the radius is going to only be, from the center out once. It's not all the way across. So I feel like that's it. She's just forgetting that one step.
So instead of actually measuring the diameter, he just applied it and got the answer. And then reset it up to look like he did the work.
In this case, I'm going to say it really publicly if she's in a group. The way you are so meticulous, the way you showed your work, I can see your thinking. And so it makes it really easy to track back and analyze what's going well and what needs to be corrected. That kind of meticulous step-by-step effort when doing these kind of calculations, it's critical. And it's all there on your paper.
Yeah, and then she plugs it in again for the radius instead of doubling it to get the diameter. Yeah.
So she's saying they're the same
Maybe it
thing,
would help her
essentially.
also to write the formula, as she's answering it. So when you're plugging it in, you're like, okay, I'm plugging in D, but I'm given R. So what's the relationship between D and R?
And it seems like she's attached to thinking about it in terms of radius, so she can use that, right? She can start with the radius, multiply it by 2, and then continue.
So I want in your groups now, I want to report out and I want you to practice this most difficult and sophisticated of teaching skills, which is giving feedback to students that both fosters their learning and, when appropriate and necessary, if you can even build on it, to foster their social and emotional welfare, their resilience in mathematics, their growth mindset. So we're going to hear from just a couple groups. You guys have Julia, yes? Yes. So Julia has done the bubble, she's done the bubble activity, but now it's a couple days later, and I've assigned some problems in the book where students are using radius or diameter to calculate circumference. And tell me about her work.
So we saw in Julia's work, she's showing all of her work so we can really see her thought process. And what she's doing is the book is giving her either radius or diameter and asking her to find the circumference. So what she's done is she's forgetting that radius and diameter aren't really the same thing. So when you're using them in a formula, you have to adjust. So when they gave her diameter, she did the formula correctly. She multiplied it by pi and got circumference. When they gave her radius, she did the same thing. But radius is not diameter. So we think she needs a refresher on that relationship. So Jeannie had a great way of saying that if you want to give the feedback.
I'm Julia.
So Julia, it looks like you're doing really great work. You're showing all your work, and I really, really like that. But can you tell me, by looking at this picture, the difference between a radius and a diameter? Do you think it's exactly the same thing? If you look at this picture right here.
Oh. No, the radius is a little short guy.
Yeah, so it's actually half the diameter. So if you're looking back at your work, and even looking at the equations, if you want, in the book that provides you, what do you think you should have done differently for these two questions up here?
Okay, where it's R, I need to double it. And you know what? I don't have to do it all over. I can either just double the R, or I could just double my answer, because all I need to do is double a factor or double the answer.
Good.
Save myself some time.
Yeah, can you do that for me? Thanks.
I want to say there's some real opportunity to work a little bit with growth mindset with Julia, because she's got it. Yeah. And how does she have it? When you talk about, you said, you showed your work, it was really nice and meticulous. Can we add on a little something that is, when we work that way in mathematics, we learn more because we're really identifying how I'm thinking about the problem. So if I might add on to yours, I can't emphasize enough how clearly you showed your work, how I can see you're setting up the equation. That makes it really easy for me to see your math, to understand how you're thinking, and it helps you reflect on your thinking, and it makes it so easy to fix a small mistake like that because it's all right there. And that's a really important math ability, to be so meticulous, to be step by step, to clearly organize your thinking and represent it. Thank you, Julia. All right, Julia, we have, in contrast, John. John has done, now John's work product is not from the book, it's from the activity where students were asked to do their bubbles and measure the diameter and the circumference. And John's worksheet is complete, and I'm going to leave you guys in group 2 to talk about John's worksheet a little bit, and then think about, yours is a tough one. What's your feedback? And we can bounce it around, the whole group. So tell us what John did so we have something to work with.
Okay, so John had to, of course, blow the bubbles and find the, well, I guess in our sense, yeah, find the circumference and then diameter and the ratio of C to D. And we noticed right away, well, Cassie did, that he used the 3.14, which of pi, after he found the circumference, and that's what he got for his diameter. So we kind of noticed that he did a shortcut.
So it looks like he didn't actually measure the diameter. He just took the circumference, divided it by pi, and wrote down the answer because it is exactly 3.14 for each of the answers.
One of his measurements is like 12.04445, and that's supposed to be a measurement, right? So did you have any feedback for John?
I don't know if we talked so much about the feedback that we would tell him, but I guess if, since we know that he did divide by 3.14, next time maybe if he wanted to actually show the work, all of it, and not just exactly, okay, well I know I'm going to use 3.14, but instead, can you maybe, how you got there, and so if you needed to teach someone else next time, don't just say, okay, use 3.14 and not have an explanation to why.
Yeah, fair enough. John knows something that's really important, and he needs to do something. Katie, you were going to add. Go ahead. We have many teachers in this room.
So I don't know if this is along the inappropriate sarcasm, but if you asked him, oh, it was 3 point whatever, measurement, can you show me where that was on the ruler? Like if the ruler doesn't actually go to that precise of a measurement, if just pointing out like, oh, you measured it on the ruler. Where was that on the ruler? Where did it go on the ruler? I guess I've had some students in my class that when I've pointed out that like, wait a minute, you couldn't really do that, and they kind of like laugh and fess up and, oh, well, I did it this way, So maybe redirecting it to making sure that they were actually measuring it out?
Could.
Or do you think that would be
There are many
negative?
options, and there's a price and a payoff for every single one. I'm going to give you a Patty Swanson response. One of the things I would suggest you guys cultivate is start with just say what you see. John, when I look at your measurements, I can tell you measured diameter, but that you didn't measure circumference. You used the formula to get it. Now's the good part. I know you can use the formula. You use the formula extremely well. You've got it on every one of those. It's very meticulous. You've used the formula. However, where we were trying to go is to understand the relationship between diameter and circumference. And you can't do that because you just used the formula. I wanted you to measure both and figure out what was that relationship. And honestly, I wanted you to do what's mathematically important. I wanted you to try and prove that's relationship with your numbers. And that's where you haven't gone because you haven't measured both of them. You've got the formula, prove it. Prove it is the formula. Prove that it is about 3 and prove it by your measurements. So you have one of my favorite work samples, which is Cecilia's work sample. She's doing the toy rates. She's written out her rates on the table, and she's done her unit fractions, and she notes that her toy is slowing down and her unit fractions show it, or her unit rates show it, excuse me. And Cecilia was a student, she was a newcomer, she had huge deficits in terms of what she knew in mathematics, but this day she was on it, and Cecilia would try and keep up, and she would always ask me, how do you do it, how do you do it, how do you do it, in this frantic, I'm going to hang on with what we're doing here. But this day she didn't say, how do you do it? This day she said, it doesn't make sense. My fractions are getting bigger, because the numbers were getting bigger, not the fractions, but my unit rates are getting smaller, and the toy slowed down, and it doesn't make sense. And I knew something really important happened for Cecilia that day, but I struggled with, I was, in my mind, I was saying, oh my gosh, how do I reteach fractions? And then how do I tie to rates? But there was something more important that was going on. What thoughts did your group have on Cecilia and her comment and what she says?
I think when discussing it, we focused on that in her confusion, she has really hit the nail on the head of what this whole purpose is. It's to show that even though the distance is always going to increase, the toy isn't going to move backwards, the time is always going to increase, we're not going to go back in time, but the rate of how quickly the toy moves will change and fluctuate. And that's really the purpose of the lesson, and her saying, I don't understand it. There may be other, like you said, the confusion between ratio and fractions, but she has really distinguished what we were trying to get them to all understand is that the toy will always keep moving forward, but it may get slower, it may get faster, it'll change. And to really focus in on, even though she's confused, she has summed up the lesson and what the purpose is.
And that's what you say to her. Cecilia, your question is the very essence of what this lesson is about, which is trying to determine the speed of the toy and how it changed. So again, you can start with just what you said. That's exactly, she's got it. It's a great question. I want to open up to the class just one part of her question because I think it ties in with this whole idea of a respectful community. Because Cecilia was a low status student in mathematics. And I want to point out she said something that is the very essence of becoming good in mathematics, which is growth mindset. She said, it doesn't make sense. Cecilia had never said it doesn't make sense. She didn't care if it didn't make sense. She just wanted to know how to do it. On this day, because the task was highly engaging and she collected the data herself, and the data didn't make sense. So she's doing the very thing you need to do. She's embracing the challenge. What was that phrase again?
Challenge accepted.
Challenge accepted. I'm going to figure it out. And when you do that, you learn. And her potential for learning for this day was gigantic. And I want to say, I can say to the class publicly, Cecilia did something today that is the very essence of doing mathematics well. She said this doesn't make sense, and then she persevered and she was trying to figure out how did it not make sense and what am I going to do about it. And it was a turning point for her. It was the most important day of the year for her in that classroom. And I need to acknowledge that saying it doesn't make sense and wanting to grapple with it is one of the most important things you can do in mathematics. It's the very essence of setting yourself up to learn. And on this day, she did it. And she was thinking like a mathematician. And that I can say publicly. So on this day, we started with the issue of G. In the upper grades, kids are really struggling with math, and it started with learning. But we have throughout the day explored ways where it's about the intersection of how students feel about math, whether they think they can get better at math, whether they are taught to persist in math, whether they feel safe to embrace the uncertainty of math. This class was about how we try and develop those skills with our students. I make the argument that it's not a separate lesson for me, it's embedded in the very essence of how I'm teaching math. And we looked at it in terms of classroom environment, we looked at it in terms of feedback that we would give kids, the kind of daily interactions I have with kids and the messages I want them to get about what does it mean to do math, what does it mean to learn math. It's based in a balance in my curriculum between highly engaging, relevant tasks and also, yeah, math is hard work. It takes practice, it takes diligence, it takes study skills. I want my class to include both from a mathematical perspective, and in each situation, I'm trying to foster and build children's resilience, their social emotional well-being, and give them the social emotional skills which are critical to learning math well, and quite frankly, are critical for life.